Hi everyone, so this video is for section A, which is revision of expansion laws. So before we get to expansion laws, I want to take a minute and just talk about how do you actually multiply algebraic terms together, because that might be an area that hasn't been covered for some students. So if that's you, this section's for you. So if we look at this first example of 3a times 2a, the way that you multiply algebraic terms together is you multiply the numbers by the numbers, or the coefficients by the coefficients, and then you multiply the letters by the letters. So in this case, the first thing we're going to do is we're going to multiply together the 3 by the 2 to give us 6, and then we're going to multiply a by a to give us a squared. So our final answer on that one is going to be 6a squared. So if we look at the next example, again, starting with the numbers by the numbers, so 4 times 5 will go first, and that gives us 20. And then x squared times another x gives us x cubed, x to the power of 3. Because remember, x squared is really x times x, and then we're multiplying that by an additional x. So x multiplied by itself 3 times will give you x to the power of 3. In the third example here, we're looking at multiplying the numbers together first. So 3 times negative 7. So a positive times a negative gives you a negative. 3 times 7 gives you 21. And then we have x in the first term and no variable in the second term. So that will just be x. Okay, so now let's get to some of the actual expanding laws. So we're going to look at 2, and then we're going to look at a couple of special cases for the second one. So the first one is called the distributive law. So this one is used when you have a term that is being multiplied into a set of brackets or onto a set of brackets, however you want to kind of think about it. So you've got a number or some kind of term. It could be numbers and letters. It could be just letters. And that is multiplying into a set of brackets. So in order to do this properly, you distribute, that's where the distributive law comes from. You distribute the multiplication of that term outside the brackets onto each of the terms inside the brackets. So the first thing we're going to do is multiply the 2 by the 3x using the rule that we just talked about. So numbers by numbers, letters by letters. So 2 times 3x is going to give us 6x. And then we're going to multiply the 2 by the next term in the brackets, which is negative 1. That negative has to go with that number. So 2 times negative 1 gives us negative 2. So our final answer here is 6x minus 2. On to the next one. So we've got negative 3x, and we're going to multiply it first by the x. So that's going to give us negative 3x squared. And then negative 3x times 2 gives us negative 6x. The only thing that I'll mention here that you need to watch out for would be a question like something like this. Let's do like 3x minus 2 and then multiply by x plus 4, something like this. Lots of times students want to try to do something with this subtraction before they do something with this multiplication. Order of operations tells us that the multiplication has to happen before the subtraction. So don't let a question like this kind of trip you up a little bit. So for a question like this, the 3x just kind of stays and kind of just waits around for a few minutes. And then we're going to take the symbol with the term, multiply that into the set of brackets. So negative 2 times x gives us negative 2x. Negative 2 times positive 4 gives us negative 8. And then we would look to see if we have any like terms and combine them if we do. And we do. We have a pair of like terms here. So we're going to put those together. 3x minus 2x gives us x. And then the minus 8 has nothing else to collect with. So x minus 8 would be our final answer on that. So that's how you work kind of question where you have a term multiplying onto a set of brackets, a single term multiplying onto a set of brackets. So now we're going to look at what do you do if you have 2 sets of brackets and each of those sets of brackets has 2 terms in it. So this 2 terms is called a binomial. That will come up again later. So it's a binomial and we're multiplying 2 binomials together. So we do this acronym called FOIL. So FOIL stands for first, outside or outer, oops, not outsider, outside, inside, and then last. So it's a series of 4 multiplications that kind of outline how you navigate through this multiplication. So the first multiplication we're going to do is the first 2 terms in each set of brackets. So in this case, it would be x times x, which gives me x squared. Then the next multiplication we're going to do are the outside terms. Outside in this case means furthest from the inside. So in this case, it's the first term in the first set of brackets and the last term in the second set of brackets. So x times negative 2 gives me negative 2x. Then the next multiplication we're going to do is the inside terms, which in this case is 4 and x. So that gives me plus 4x, positive 4x. And the last multiplication we're going to do is the last 2 terms, which is 4 and negative 2 to give me negative 8. So you'll notice by the color coding that each term gets used twice, right? The first term here gets multiplied by the first term and then the second term, and then the second term gets multiplied by the first term and then the second term. So then, last step is collect any like terms. 95% of the time, the like terms are going to be the middle 2 terms. So most often you will find you end up collecting the middle 2 terms. There are no other x squared, so that just stays x squared. Your middle 2 terms, we're at negative 2x plus 4x, so that gives us plus 2x, and then nothing else to collect with our constant term of negative 8. So final answer here, x squared plus 2x minus 8. Next one, same thing. First, we're going to start with the first 2 terms. So 2x times negative x gives me negative 2x squared. Outside terms, 2x by 4, so that gives me plus 8x. Inside terms, 3 times negative x, negative 3x. And last terms, 3 times 4, plus 12. Then look to see if I have any like terms to collect. I have no other x squareds, but I do have 2x terms, so those need to get collected together. So final answer, negative 2x squared, 8x minus 3x, positive 5x, plus 12. So 4 multiplications, first, outside, inside, last. So let's look at a few special cases here. And these will become more important sort of as we move through this unit. So a difference of squares is a particular kind of setup where the two bracketed pieces are identical except for the symbol in between the terms. So we've got x plus 3, x minus 3, identical except for the plus and minus. There is a bit of a shortcut for these, and some of you will certainly get to the point where you're using that shortcut regularly, or you may already be there, and that's fine. If you are not sort of at that shortcut spot yet, FOIL will still work. First, outside, inside, last. 4 multiplications. So first, we're going to do x by x, giving us x squared. Outside, x times negative 3, so negative 3x. Inside, 3 by x, positive 3x. And last, 3 times negative 3 to give me negative 9. So again, we look to see if we can collect any like terms. And as I said, almost always it's those middle 2 terms. So the interesting thing that happens with this question is there's no other x squareds, but negative 3x plus 3x gives us 0. So those middle 2 terms effectively cancel each other out, and we're left with minus 9. So if you've been kind of paying attention to vocabulary over the years in your math career, you will notice that what we have remaining is a subtraction, which is in math terms a difference, and then we have x squared and 9. Both of those are squares. They are perfect squares. So this is a difference, a subtraction of squares. That's what we end up with. So these two factors, identical in the brackets except for the symbol, will lead to a difference of squares. So the next example, same idea, first outside, inside, last. First, 3x times 3x gives us 9x squared. Outside, 3x by 2 gives us plus 6x. Inside, negative 2 times 3x minus 6x. Last, negative 2 by positive 2, negative 4. Look for like terms. You'll notice again, those middle two terms cancel out. So what we have left is 9x squared minus 4, a difference of squares. Last kind of specific example are called perfect squares, where you have a single set of brackets raised to the power of 2. So what you need to know is what that actually amounts to is that set of brackets multiplied by itself, multiplied by that exact same set of brackets again. But again, there is a bit of a shortcut for perfect squares. Some of you may know it, some of you may use it. If you don't, that's totally fine. FOIL will still work. So first, 3x by 3x, 9x squared. Outer, 3x by 1, positive 3x. Inner, 1 by 3x, plus 3x. Last, 1 by 1, plus 1. So what you'll notice here is that those middle two terms end up being exactly the same. That's kind of interesting and will become more interesting in a few classes. So again, collect up your like terms. And so we end up with 9x squared plus 6x plus 1. And then the last one here, again, 2 minus 4y multiplied by itself, 2 minus 4y. What a lot of students will want to do is take that exponent and just apply it directly to both of those. That's illegal. You cannot do that in math, so don't do that. You must FOIL or else use the shortcut for perfect squares. So again, if we multiply by FOIL, first gives us 4, outer gives us negative 8y, inner negative 8y, last positive 16y squared. Collect up our like terms. Shockingly, it ends up being the middle two terms. We end up with 4, negative 8y minus another 8y, negative 16y, plus 16y squared. So that's another special case called perfect squares, which again will come up a little bit later on. And that's about it.